First, I want to make sure that we can hear.
Yep.
Perfect. Thank you. So again, Julia said this is Dina Wyatt. I'm with the GDS Associates office out of Madison, Wisconsin. And we just want to go through a short presentation where I can touch on a few grain drying methods and selections. So to basically get started here, we'll touch on the very basic physics of grain drying. And drying grain is the evaporation of water. Air removes water because the relative humidity of the air is lower than the humidity of the grain. The drying zone, which in the picture to the left is shown in yellow, or they call it the drying front, is where the area of the wet is evaporating to dry. So again, that's kind of the very, very basic physics of grain drying. So next, we want to touch on just some simplistic fundamentals in the one of the dryer methods, which is a bin dryer. So the drying starts at the bottom of the bin. Dryer is brought up by a fan through about a 1 to 2 foot layer of wet grain. Again, that is called that drying zone, which in the earlier slide was that yellow zone. The drying zone moves from the bottom of the bin to the top. Grain is dry when it reaches that highest layer. So it's moving again from the bottom to the top. The grain below the drying zone is in equilibrium moisture content, which is, they refer to the EMC, with the drying air. So this means it's safe to store. There's then forced out through the exhaust vents. We'll just go back to that other slide. And again, you'll see how the fan and the heater, if there is a heater, work and transition of the air through the floor, through the grain to the top. So we'll move on to the next slide, which will be, I just want to touch base on some methods. So we'll briefly talk about in-storage, batch, continuous flow. And in this, dryers are categorized in many different ways. So natural air, low temperature, high temperature, batch, automatic, continuous, in-bin, column, self-contained, towers you may hear of, or verticals, and so on. There's a lot of different names for categorization of them. But dryers are also classified by the direction of the airflow through the grain. So we're going to touch a little on the cross flow, the counter flow, and the concurrent flow. So one in storage drying method, which basically means you dry and store in the same container. Low temperature natural air drying uses little or no additional heat. In some cases, they do have to add heat, which again will be coming through that fan through the bottom of the floor. The advantages of it is the bin's filled at the harvest rate. So you're taking it off the field, filling the bin. It's economical if it's sized properly for your harvest. The disadvantage is that they take weeks, and several weeks to, if not more, to dry. The low airflow could also cause some spoilage. This method is considered to be one of the most efficient out there. However, the dryer is not optimal for high moisture grain. So there's a limit to the moisture content that can be dried, and you may need to add heat. But you also need to have an electric power source at each bin for that dryer fan motor. So the next option would be to go into an in-storage multi-layer drying. So in that sense, it's almost the same as the low temperature, the natural air dryer, but the grain goes in the bin in layers. So that initial layer of about 4 to 5 feet is put into the bin or dropped in the bin. The drying is started, and then that drying zone is established. That's moving again through the grain to the top. More layers are placed on top of that or ahead of the drying zone. So in this situation, The layering the grain is an option to get a higher airflow rate to allow for drying higher moisture grain. Again, spoilage can happen if the grain is added too quickly. So, as you can see in the picture, it'll show the different layers. And again, this is really similar to the natural or the low temperature, just with putting it in layers. Then we want to move into a batch drying method. And there's the in-batch high temperature. So this then again is real similar to the other ones, but you're adding that heat. So the typical temperature is pushing through there are 120 to 160 degrees Fahrenheit. The grain is cooled in the bin after it's dried. So that, some people look at that as an advantage of space saving. They don't have a lot of acreage to have multiple bins. So wetter grain can be added. It can be transferred to the low temperature bin if you have available space for that. And then the bin can be used for storage at the end of the season. So a disadvantage, or a couple of them, would be possible large moisture variation, and the bottom layer may become too dry. With this, you could add a stirrator, which adds capacity to that bin. So studies have shown that adding a stirrating device could increase the depth of the grain from that 3 to 4 foot up to about 7 to 8 foot capacity, and also increase the efficiency for the drying. So moving into this next slide, we talk about bin batch drying solutions. So utilization of a full perforated floor. So the whole bottom floor is perforated to get even heat distribution going up through the grain. Adding that stirring system, adding a sweep auger to recirculate the grain. So it'll make a complete sweep of the bottom floor, pull it up back to the top of the bin, and drop it back through so it recirculates that in that batch dryer. And again, it's drying it as a batch, so it's staying pretty much in that bin. An option is also to have a roof dryer, which is really similar to this, with the perforated drying floor near the roof of the dryer, where you'll have the fan and the burner high on the wall. Once that grain is dried, it drops down to the bottom of that bin. So another option would be the column batch drying. So this bin has the wet grain supply at the top. It's completely filled at one time. The typical sequence of this dryer is to fill it, to dry it, to cool it, and then unload it. But this is all, again, happening as a batch. So the average is 2 to 3 hours per batch. There's high temperatures and high airflow. The plenum in the middle, the heat chamber, has the columns surrounding it, where the grain drops down those columns and the air is pushed through that to dry that. The advantages of this dryer would be that it has that wet grain supply at the top, so you're not just dumping it all in at once and having it come through the bin. They are portable. Well, most of them can be very portable units, easily moved to a different location or reset. Disadvantages is the heat in the dryer isn't really used very efficiently. So once it's in, it's out. It goes through the grain and it's done. So they say it's not very energy efficient. And it takes a lot of hand-on operation, which is the handling of the grain as well. Such as in the previous slide with the batch multi-layer, I should have touched on where before you can put your next layer in that multi-layer, you do have to monitor that moisture content of the grain to ensure that it's dried appropriately before the next comes in. The continuous flow drying methods, again, we're looking at this as in the direction of the airflow, so the cross flow. where the airstream is perpendicular to the grain flow, and it is pretty much the most widely used. We're here in Wisconsin, and I'm pretty sure pretty much everywhere. The concurrent flow, grain and air moving in the same direction. It's said to have a bit more energy efficient compared to just your standard cross flow dryer. And then the counter flow drying, where the grain and the air are moving in opposite directions. So the driest grain is really subject to that hottest drying air. I'll move to the next slide here. I want to talk a little bit about the continuous flow bin dryer. And you can kind of see a pattern of the bin dryers and basically how they work with the filling of the grain, the perforated floors. So in this continuous flow bin, the wet grain placed on top of the grain, or on top of the drying grain. So there's kind of an elimination of a need for a wet bin, so you're just basically putting it all in that same bin. As the heated air rises through the grain during that drying, it picks up moisture and preheats the wet grain. There's an automated control system that periodically will sense the grain moisture, and if that grain is dry, that sweep auger we spoke of earlier makes one full rotation on the bottom of the bin to remove a layer of dry grain from the bottom up to a storage bin. So that grain that's dry on the bottom is being intermediately removed as it dries and then transferred to the storage. Well, it's still hot. So that's where that cooling is going to begin. So the bin now is basically a dryer, and that grain is being moved. So just to touch a little bit on the continuous cross-flow dryers, which, again, are very popular, but I said not to be the most efficient dryer out there. The first picture is showing the cross-flow horizontal dryer with forced air. So you'll see that it has a split air funnel in there where you have the cooling fan to the bottom and the heated air to the top. Again, the wet holding bin at the top where the grain is coming in, flowing down the columns and being heated. With this continuous cross flow, you're not recirculating grain and it's not staying in there. It's being dried, cooled, and then removed. So to a secondary bin for storage. The second picture, just to have that for reference, would be an added option of reverse flow cooling. This adds just a bit to increase the efficiency of that dryer. The third is the concurrent flow with counterflow cool. Again, an option to have something be the grain dryer be just a bit more efficient. So, and with this, you can see that grain flow and the hot air flow are in the same direction, which is concurrent, with the cooler pushing up through to grab that counterflow. So moving into that horizontal continuous cross flow, again, the wet grain constantly feeds to the top of that dryer and is dried and cooled. Dry grain drawn off that bottom and placed into storage. Real similar to that column batch dryer, but again, it has that divided plenum chamber. The hot air is pushed into the top chamber and unheated air is pushed into the lower chamber for cooling. A sensor then controls that discharge rate of the grain. So again, that's just a continuous movement. It's being filled, dried, cooled, and then it is out of the dryer and into storage. Another continuous cross-flow dryer, tower dryer, also called vertical dryers. The heated air blows across the grain as it flows by gravity down 8 to 18 inch wide column. It has the cooling section at the bottom. It has a heated section more towards the center top. And again, there's sweep augers or paddles that remove the grain to a storage bin. So as the grain is flowing down through this, it's drying, it's cooling, and the paddles sweep along the bottom of the dryer and are moving it to a bin. One of the more rare, but I've seen them come about a bit more through Wisconsin, would be the continuous mixed flow dryers. And they're said to be one of the more or most efficient dryers out there. And this is where the grain flow provides mixing of the grain and an alternate exposure to the hot drying air and the air that has been slightly cooled by previous contact with the grain. So the grain flowing over these alternate rows of heated air and air exhaust ducts comes down. It's, again, if you can kind of look at the picture, you'll see the grain flow coming down where you'll have the heated ducts and the cooling ducts. So they say it uses a lower airflow rate per bushel compared to the other dryers, where again, that's where they're saying it would be more efficient. And it does have a promotion of more uniformity to the moisture content because that grain has a real near or equal exposure to the drying air. So they say it gets that more even drying again. And as it comes down and is dried and cooled, it is then again moved to another bin. So when selecting a dryer, there's a lot of different things that you really want to consider. So with how many bushels are you harvesting, your acreage, what's your space availability for future growth, buying more land, drying different crops, what's your typical moisture content. I know that my fields are very wet, so everything coming off them is very wet. Do you have three-phase service that could be available? Do you have natural gas as an option, or are you straight electric or LP usage? What's the cost of the dryer? What's the cost of efficiency options? And again, it's all sits and is based on what fits your drying needs. So there's an awful lot and really too much to cover all in this presentation. So in simplicity, we're just, again, touching on those few methods and then options of selection. And most of these dryers will all come with a variety of energy efficient add-ons. So your current dryer could be made more efficient instead of buying a new one. So the best dryer out there, with all that being said, is the one that best fits your situation, your grain harvest, and is most efficient for you again. One of the things that I guess a lot of people don't take into consideration is this is mechanical, so it does need maintenance, or you're going to lose that efficiency level and operation of that dryer. So I always recommend, contracting with your manufacturer to schedule the checklist of cleaning. If you are doing it yourself, if you happen to be able to stay on top of that, do the pre-season cleaning, during the operation cleaning, and a post-cleaning. Clean the entire unit, removing all the fines and debris. Make sure you're lubricating the bearings, checking the belts for tightness or adjustment, the wiring
we've got
condition.
A question here.
Sure.
All right, we've got, what is the highest moisture content that the first type of dryer, the natural air low temperature, can efficiently handle?
You want to keep that down to the 24% or less, I would believe. And I can, we keep all these questions. I can definitely get back with everybody on the specifications of each drying method to ensure that I'm giving the actual accurate data that they're looking for. So coming back into just the maintenance and keeping your dryer running up to optimal performance, again, with that checking of the wiring condition, a lot of the insects, bugs, and mice, they tend to like to live in there and chew, so you just want to make sure that's all good to go, no loose wires hanging anywhere. The physical structure of the bin, a lot of snow and fines cause that rusting. So you just want to do a walk around, make sure the physical structure is in good condition. And then check burners for clear holes. Typically, you want to contract somebody to do that to make sure that it does meet manufacturer specifications. They'll typically tell you what size bits you need to clean those holes. But, again, I would always talk to the manufacturer about that. And then just kind of wrapping it up, properly maintained, your dryer will give you many years of efficient service. And you can, again, add on to it if need be, or, search for that new dryer with the more efficiency option. I would have to say if there's any other questions, again, we can go through any questions that I might be able to answer, or again, in specifications, I can definitely pull some of that information for you for each method and get that information out.
All right, while we're waiting for people to type in some questions for Dina, I just wanted to go through our upcoming webinars. In May, we've got some niche agriculture, specifically talking about maple syrup production, and that is done by Joe Schultz. In June, we've got Bethany Reinholtz talking about innovations in agriculture. And in July, we have Joe Schultz coming back for a talk about biogas. So we do have our schedule finished for 2016, but those are the next few months. And again, if you are interested in any of those presentations, go ahead and sign up for them on the website as they become available. And again, if you have any other questions for Dina, her email address is on this slide, and the next one also is, if you prefer to call, we do have an 800 number for our GDS Associates Agricultural Services group, and you can always contact them with any other questions on some agricultural subjects. And I'll wait a few more minutes here. I don't see any questions quite yet, but I know sometimes it does take a while to type in, so we'll wait just a few minutes here, and then we can get you on the rest of the way of your morning here.
Just to touch on that natural air bin dryer again with low temperature, that moisture content, 23 or under, I've read studies in there, 22%, but I've seen it go in at higher levels and considerably lower. And I think it has a lot to do with operation, operator.
All right, manual controls versus computerized controlled energy savings.
I'm sorry, what was that?
A question from Josh: manual controls versus computerized controls, energy savings in grain dryers.
Well, I think it comes down to your time availability and hands-on. So if you're looking at manually probing and testing the corn so you know when to add another layer or when to remove it from the bin, again, in variation. So in the continuous flow drying methods, the
Josh does say
computerized...
for natural air bins.
Oh, for natural air bins. Typically, I don't see a lot of the computerized controls in the natural air bins that I've looked at. It's a lot of what I've seen has been kept to the bare minimum, very organic, probing it, hand probing it, testing the moisture to know when that grain is dry, and then adding a possible recirculation. But again, that recirculation would have then a automated sensor in there saying the grain is dry, pulling it up through that column and dropping it back to the top. So efficiency-wise, again, I'm pretty set that it's not going to add energy efficiency as much as it's going to take away your hands-on monitoring.
All right, I don't see any other questions. Again, Dina is always available by email if you have any other in-depth questions for her. And again, thank you for sharing a little bit of your morning with us. And if you have any other questions for Dina, go ahead and email her. This presentation has been recorded, and I will get it out to you all as soon as the link is available to me. Thank you, and have a great morning.
Thank you.